Hey guys, it's Mr. Calderon with Queen My Pawn, and I'm going to be talking about angles and their attributes. So when we have an angle, we have some separation of space between two lines. I'm going to show you what that looks like on my tablet. So I'm going to share the screen to my tablet, and here we go. So let's say that we have the regular X and Y plane. So over here, I have the X and I have the Y. And let's say that I drew a line right across the x-axis like this. So it's flat, it's on the x-axis, and then I start going up with it. So this is a starting point, and then I go up that way. Let's say I stop here. Now I draw another line from the origin to there. So it kind of looks like a pizza. Well, that's the separation between those two lines is the angle. So I'm going to draw the angle in red. However big that angle is, that's the amount of separation. It's measured in degrees. So I could put something like 45 degrees here. That's a decent amount of separation. Now, you may notice that I drew it from the x-axis, and then I went up, and then I stopped somewhere. When you start from the x-axis, which means you just start horizontally, and at the origin, which is this spot right here, that I made a dot in red, you made an angle in the standard position. The standard position just means that across the x-axis is where you start and at the origin. When you look at a clock, such as that I have in blue over here, like the ones in your classrooms, you tend to start at not the standard position, right? You tend to start at the 12. And when we go to here, and let's say that we want to go to 2 o'clock, well, this would be the angle, and we would go in this direction. Well, this isn't the standard position because you haven't started at the x-axis, you started at the y-axis. But you can still find out what the degree is. Just rotate it so that it looks like the standard position. Now, you know that the difference between the x and y-axis is basically a quadrant. And quadrants have a degree of separation like a square. So look at the square that I'm going to draw in orange. See that square right there? You learned in geometry that that's a right angle. Quadrants differ from each other by a right angle or 90 degrees. So if we want to draw this clock that I have in blue in standard position, I just rotate it 90 degrees towards the x-axis. So I'm going to have this in orange and I'm going to keep the numbers the same color. So I have a 12 and I have the 2. And now you can see that I started in standard position because it looks like I'm starting at the origin and then I'm going towards the 2. Now my angle is going backwards. As you can see, it's going down, but that's okay. Right now, I'm not concerned with the direction. I'm just concerned that it's in the standard position. So that angle, I'll leave it up to you as an exercise to find out what it is, but you'll definitely learn how much space there is a separation by the end of this lesson. So now that we've defined standard angles, that standard position of an angle, we can talk about pi. You know pi because you put it in a calculator. Pi equals 3.14 and so on. Back before the Common Era, which means before year 0, there were a lot of people, Chinese, Indians, Greeks included, that try to figure out exactly what this number is to its fullest extent. Well, one time a group of people actually got together and they got logs and they placed them around the circle. So this circle right here is made up of logs, and it looks something similar to this. The logs are in brown. So we had one log like this, and then another log like this, and so on. You can see that there's some separation between the logs, obviously, so it's not perfect. But the people found out that they could put 22 logs around the circle. Now, they went through the middle of the circle as well, and they put the logs like this. They got to the end, and they found out that there were 7 logs that they could put in the middle through the middle of the circle. So on the outside of the circle, we call that the circumference. It's the perimeter around the circle. So we'll label it C. Remember, circumference just means around something. So if you go around your house, you just walked the perimeter. But circumference is a special perimeter. It's for circles. And since we go through the middle, we have 7 logs. We call it the diameter. Well, if you put that in your calculator, you're going to find out that you get 3.1428 and so on. So the same group of people decided to chop off the logs so that they could minimize this amount of space. And as they got more and more logs, little pieces, they got closer and closer to the real number. It went from 3.1428 to 3.1421 to 3.1417 and so on. And eventually they got closer and closer to 3.1415 and so on, which actually turns out to be pi. But they didn't discover pi right there. It took a little bit more for Archimedes to prove that pi was actually that number, or close to that number. So we're not going to discuss that, but that's where pi comes from. Pi is the ratio between the circumference and the diameter. Ratio just means that you're comparing 2 things. You're comparing the circumference here, and you're comparing the diameter. You can use ratio anywhere, like in your classes. If you have 10 boys and 10 girls, then you have a ratio of 10 boys to 10 girls, or for every boy, you have a girl. So the ratio would be 1 to 1, and you would write it something like this. Not drawing, 1 to 1. That's how you draw it. Okay. So that's ratio, circumference to diameter. For every 1 diameter, you have 3.14 circumferences. Or no, for every 1 circumferences. For every 1 time you go around the circle, you have 3.14 diameters. Okay. That means you can go 1 time around the circle, and you can go 3 times through the middle and a little bit more for the same distance. Now that we've discussed that, we can continue. So now let's talk more about angles. So if we go all around the circle, so we start from here and then we go this way, 1 whole revolution is defined to be 360 degrees. Let's say that I start at the standard position. So I draw a line through the standard, through the horizontally to the end. So it looks like a radius. And then I draw another line right here. Let's say that angle is 135 degrees. Well, if I go from here to, if I start from here, the same line as the other angle, and I go around the circle once, and then I go a little bit more, and I end up at the same spot where the other angle ended, they will be coterminal. Coterminal means that you end up at the same spot, but you also start at the same spot. So we both started at this line right there. The white and the orange angle started at the same line, and then they ended up at the same line. Another way to think about it is this. Let's say that you are with a friend and you're in a track, but it's a circular track, which they don't exist. but let's say they did exist. So you had a circular track. Your friend decides to walk from here. Actually, let me not draw a line. Your friend decides to walk from this spot in red all the way to here. So they basically just walked here. You can just create an angle there and determine how much space that is. We could say it's 45. But you want to take, and let's say that, you are there with your friend. Here, your friend stops and wants to sit down for a little break, but you decide to walk one more lap. So you don't stop there, you keep going. And then you end up at the same spot as your friend. You both ended up at the same spot, except you walked one more lap. However many laps you walk, that doesn't matter. It just matters that you end up at the same spot. That's called coterminality. So you walked one more circumference. You also walked 360 more degrees. They're the same thing. So you walked that many more. You both walked 45, but you walked 360 more. So this is how many degrees you walked. 405 degrees. We call that angle coterminal. You can walk backward and subtract 360. So let's say that you have 45 minus 360. Then you should get negative 315. That's if you go backward. In blue, it would look like this. You start from the same spot and you end up at the same spot. You start from the right there, okay? And then you end up right there. You can tell that the angles are coterminal because the blue overlaps the red. So that's basically it for coterminality. So anytime you're wondering if an angle is coterminal, you can do two things. You can draw a circle and draw the angle. Or what's easier is find out if they differ by 360. If they don't, for example, negative 45 and 315, do they differ by 360? If they differ by 360, they are coterminal. But let's find out here. Well, the difference between these is actually 360. If you do 315 minus negative 45, that will equal 315 plus 45 because two negatives make a positive. And that'll give you 360. But let's say I had something else. Let's say I had something like negative 45 and 375. Oh, not 375, sorry. 405. Some people may make the mistake and they think, oh, 405 minus 45 is 360. So they're coterminal. Well, look what you did. You said 45, not negative 45. So it should be 405 minus the second angle, and you can tell by putting it in parentheses, negative 45. Well, when you do that, two negatives make a positive, so you add them up and you get 450. They're definitely not coterminal. So that's how you know about pi, degree measure, standard position, and coterminality. In the next video, we're going to be discussing how to convert. And why do we need to convert? Because I'm going to define the radian. Radian right now sounds like a weird word, and it should sound weird because when I heard it the first time, I was totally confused. I'm like, what is even a radian? Like, why do they call it radian? And how is the radian useful? And why should I even care to learn it? We're going to convert between radians and degrees and talk about why that is important. And I'll see you on the next one. Make sure to like the video if you did like it. If you have any questions, make sure to subscribe and comment. And that way I will be able to help you out. So I'll see you on the